Hi everyone, this is a lesson on linear and nonlinear functions. We're going to start this lesson by going over some very important words that go with this lesson to help you understand it. All right, so our first word is a relation. A relation is a set of ordered pairs. And here's an example, 3, 2, 7, 8, 9, 12. Okay, that is a relation. A relation is a function only if each x value in the relation is unique. It does not, and the x does not repeat itself. Or in other words, the x value is not paired up with multiple y values. Okay, here's an example where the x does not repeat. In each case, it's a unique x value. If this x value was to repeat itself, then it would not be a function. Okay? Here is an example of a linear function. Linear function meaning a function that gives a straight line. So here's an example, and here's an example. Another one in black here, the line in black. So that would be a function, a linear function. This is a linear function. A nonlinear function is a function that gives us a graph that has a curve. So here's an example, and here's an example, and there will be others that we will look at. Okay, so let's go ahead and start looking at these relations and determine if these relations are functions or just relations. Okay, so let's look at this ordered pair and see if it is a function. So just look at the x values. Okay, if the x repeats, then it is not a function. Do you see that the x here repeats itself? X is paired with -2, and the same x is paired with 3. So this is not a function, not a function. Let's see if this is a function. Okay, I'm looking at the x values, and none of them repeat. This is a function. If it is a function, then list the domain. The domain is just basically the x value, so that would be 1, 2, 3, and 4. The range, that's just the y values. So that would be 1, 2, 5, and 10. That's it. All right, let's look at some more examples. Determine if the set of ordered pairs is a function. So look and see if this is a function. Again, just look at the x values and see if any repeats. If it does, then it is not a function. Well, this is a function because none of the x's repeat. Each x is paired with a different y value. So this is a function, yes. Function. Let's look at the next one. 1, 2, 1. All right, do you see how it repeats? I have 1 paired with 4, and then I have 1 paired with 8. So this is not a function. Next example. 1, 3, 4, 5. None of the x's repeat, so this is a function. Let's look at the next one. 0, 3, 3. You see how 3 is paired with 1, 3 is paired with 9. So this is not a function. Not a function. All right, let's look at this diagram here. So -3 is paired with, it goes with -1. -3, no, I'm sorry, -1 is paired with -2. 1 is paired with -1, and 2 is paired with 0. So now look at the x values, okay? None of them repeat, so this is a function. Let's look at this one here and write the list of ordered pairs. -1 is paired with -2. 1 is paired with -1. 1 again is paired with 0. Do we have a problem here? 1 is paired with -1. 1 is paired with 0. So that you see the x is repeating itself here. So this is not a function. Not a function. All right, let's keep going. Determine if the relationship is linear or non-linear. Okay, so if it's linear, it would have a constant rate. So when we look for the change in y over change in x, it would be constantly the same. Okay, see change in y, let me write that down. Change in y over change in x, in this case, is -8 over 3, and it's constantly that. So this one is linear. This one is not, because the change in y over change in x keep changing. Okay, so this one is not linear. This is non-linear, and this one is linear. So that's what we're looking for to determine if it has the same constant rate of change. Okay, we're looking for the same constant rate of change for it to be linear. So let's look at this one here. See how the y's are changing. So add 2, add 2, add 2, and add 2 here. Let's see what's happening here. Add 1, add 1, add 1, add 1. So you see change in y over change in x is 2 over 1. So it is constant. It has a constant rate. It's changing at the same rate. So this is linear. This is a linear function. When you graph it, you will get a line. Okay, let's look at this one here. Add 2, add 3, add 4. Do you see this keeps changing? So this is going to be non-linear. And that's all we have to do right now. Okay, let's keep going. Determine if it's linear or non-linear. All right, from 1 to 4, add 3, add 5. You see, I don't even have to go any further. And add 7. Okay, so this is non-linear. All right, let's see how this is changing. Add 5. I'm sorry, subtract 5. Subtract 5. Subtract 5. Subtract 5. Let's see what is happening here. Add 7. Add 7. Add 7. So it's changing at a constant rate, -5 over 7. So this is linear. Let's check this one here. -4, -4, -4. What is happening here? Add 2, add 2, add 2. So it's changing at -4 over 2, which is -2. So it has a constant rate of -2. This is linear. All right, so that's how you determine if the function is linear or nonlinear, given a table. You look for the constant rate. Look to see if it has a constant rate or not. Now, what happens if you give a if you are given a graph? Well, look at the graph. If it's a straight line, it's linear. If it has a curve, it's nonlinear. So you see, this is a straight line. So this is linear. Okay, this is curved. So this is nonlinear. What do you think this is? Said nonlinear. That is correct. What about this one? Nonlinear again. All right, let's keep going. You see this is a straight line, so this is linear. This is not a straight line. This is non-linear. Okay, this one here I have to be careful. This is not even a function. Not a function. Okay, and I'll show you why. Let's take this point here. It's located at -3, 0. This point here is located at -3, 1. This point here is located at -3, 2. This point here is located at -3, 3. Do you see how the x is repeating itself? The same x value is paired with multiple y values. So this is not even a function. Okay? All right, let's go to the next one. This is a linear function. Linear. Okay? It is a line. And this concludes this lesson on linear and nonlinear functions.